Okay, now let's look at the special use of NOT gate. But first, I want to tell you few definitions. You might be familiar with this if you are familiar with other courses of electronics. Then this might be familiar. But still, I want to just give you a quick, brief type of definition, you can say. So there are something called astable, monostable, and bistable multi-vibrator. They are circuits which produces states, either stable states or unstable states, okay, in the signal. Now astable multi-vibrator is a circuit which produces no stable, means there won't be any stable states. By stable states we mean either 0 or 1, okay. So continuously it will switch between 0 and 1. There won't be any stable state. It won't be stable with respect to time. So after some point of time it will change state, another point of time it will state change again, like this. So it will give you a feel of oscillator or clock signals, which we use generally in digital circuits. Now we will see the use of clock signals later on, but just I want to tell you that it's a circuit which will generate two unstable state. So this is 0, this is 1, 0, 1, 0, 1. So for some time it is 0, then for some time it is 1, for some time it is 0, for some time it is 1. It is not stable at one state, okay. State means 0 or 1. Whereas monostable multivibrator has only one state, okay. Stable state means if it is in 0, it will stay at 0. But if you will provide a trigger, it will change the state from 0 to 1 for some time. For some time, you can see this is the time, and automatically it comes back to the 0 state. That is what we mean by monostable multivibrator single stable state. So it stays at 0. When you apply a trigger, it will go from 0 to 1 and automatically it will come back to 0 after some time. Same thing you can imagine with 1 as well. It will stay at 1. You will provide a trigger. It will go to 1 to 0. It will stay there for some time, then again comes back automatically and stay there at 1. So it's a reverse of this thing, okay. So that kind of circuit is called as monostable multivibrator. Now the third one is bistable multivibrator, which has two stable states. Now the difference between these two is from 0 to 1 this is requiring one trigger signal, but from 1 to 0 coming back to 0 it does not require any trigger signal, automatically it comes back. Whereas here you will require trigger signal in both the cases, from 0 to 1 as well as from 1 to 0. That's why they both are stable state, okay. Unless you don't require any external force or external signal to change the state, it means it is stable, else it is unstable state. So if the circuit is in, the signal is in 0 state, 0, then you provide a trigger here, it will go to 1 state and it will stay at 1 state until and unless you will provide a trigger signal, okay, another trigger signal. It will go back to 0, then 1. So this a nice example is flip-flops, okay. It will only change the state whenever you will provide a trigger, and this we will see later on in the course, okay. So these are few definitions that I want to give. Now how we can put these definitions into our NOT gate circuit, okay. Let's see that. Okay, now let's see how you can design this bistable astable multivibrator by using NOT gate. So it's an application of NOT gate. Whenever you will connect even number of inverters in feedback, then you will generate bistable multivibrator, okay. Even number of inverters connected in feedback. So this is an example. 1 2 3 4 even numbers are there. Even number of inverters, 1 2 3 4 inverters are nothing but NOT gate. They are connected in feedback, you can see. So if you will apply 0, NOT gate will make it 1, 1 will become 0, 0 will become 1, 1 will become 0, then again it will be feeded back, 0 will become 1, 1 will be 0, 1, 0, feedback. If you will start with 1, it will become 0, then 1, then 0, then 1, this will be feeded back, 1, 0, 1, 0, 1. You are feeding from here and output you are taking from here. This is how it will look like. So if you are feeding 0, 0 will become 1, 1 will become 0, 0 will become 1, 0, like this. So you will have both the states are stable. Okay, and if you will see one state, how much time it will be there in one state, then if you will take the TPD, the time period for propagation delay, it's TPD means propagation delay. Time it takes to the time gates takes to generate output, that is what you can think of propagation delay. So if TPD is for one gate is TPD, second gate TPD, third gate TPD, fourth gate TPD. So propagation delay to generate output. So total 4 TPDs you will require, so that it will be in one state. Okay, 0 is in 0. Now how about 1? If you start with 1, 1 will be also in one state for 4 TPD. So total time period, if you will see, it will be 2 into 4 TPD, that is 8 TPD. Now it is not fixed that you always have to use 4 NOT gates. You can even use 8, you can use 6, you can use 2, depends upon the requirement, what kind of time period you want. Okay, so I hope you are able to visualize that both the states are stable until and unless you are providing feedback is there, and you can see that 0 is 0 input will give you 0 output, 1 input will give you 1 output. So they are same, they are not changing state, you can see. So this is how you can generate bistable multivibrator from NOT gate application. Now we will see if we will connect odd number of inverters in feedback, then what will happen. Okay, so let's look at astable multivibrator. If you will connect odd number of inverters in feedback, what you will get is astable multivibrator. So here you can see an example. 3 of the inverters are connected in feedback. So if you will apply 0, you will get 1, 0, 1, then this one will be feedback. Now this one will be 0, 0 will be 1, 1 will be 0, then 0 will be feedback. So 0, then 1, then 0, then 1, and it goes on and on. Okay, so it's a never ending cycle. So what you will get is dot 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 dot, means like it goes on and on. It's a oscillating kind of signal you will get. So none of the states are stable. So for some time it will be in 0, so for some time it will be 1, then again it will be in 0, then again it will be in 1, and for how much time it will stay there in one state? For 3 TPD. Sum them, total 3 TPD. Similarly for one case also 3 TPD. So total time will be 2 into 3 TPD, 6 TPD. Examples are square wave generators, clock generators you have seen. So they will generate a never ending kind of wave for some time period. Okay, so TPD is the propagation delay for generating the output by gate. Now you can generalize this. So if n number of inverters are connected in feedback, where n is an odd number, each of them are having TPD delay, then it will generate a square wave at the output whose time period will be 2 into small n TPD. Okay, so this is what about astable multivibrator I wanted to tell. You can generate astable multivibrator as well as a bistable multivibrator from just NOT gates to few NOT gates connected in feedback. If you want to know about more of this monostable, astable and bistable multivibrators, I have a full blown course named as analog circuits. It's a 33 hours course. So there I have discussed in detail. So you will see the internal circuits, how it looks like. It is just a top level of circuit I am telling you, and from the digital perspective I am telling you. Okay, so if you are more interested, you can check that course out. It's available on Udemy. Anyway.